So if I had to sum up the previous video, I would say that I was trying to tell you that size does matter. The size of the column matters. The size of the plates on the inside of the column matter, because all of this relates to time and all of it relates to separation. So it's very, very important that we really choose the proper column that we need for the particular method that we're running or the component that we're trying to separate. So we went and talked about this equation H equals L over N, where H is the height of the plate, L is the length of the column, and N is the number of plates. So I told you in that video, well, what if they do not give us the number of plates in the problem, right? Well, they can give us some more information, and we can calculate the number of plates if we need to, okay? So there's two equations here that allow us to calculate N, the number of plates. The first one is 5.55 times the retention time of the component squared divided by the width 1/2 squared. And the other equation is 16 times the retention time divided by the width sub b squared. Now, the question is, why do we need two equations? And I think that by looking at the equations, you'll know quickly why we need two of them. All right, so let's say that we get a chromatogram, and here's my baseline. And let's say that a component comes off and it comes back down and it goes back to baseline, and this is what I see. Well, the reason that I have two versions here is because it depends on what the problem gives me. What kind of information do I have at my disposal? And one of these equations is a WB, W sub B. And the W sub B, the W basically means width. And I'm looking at B, which is the base. So this is W sub B, the width at the base of the peak, right? Now keep in mind that up here at the top, this is my retention time. So whatever it meets time-wise, that hopefully is going to be given to me in the problem. And maybe they will give me the width at the base of the peak as well in the problem. And if so, that's the equation that I use. Retention time, width of the base at the peak, I square it, and then I multiply by 16. Now, sometimes the width at the base is not practical. And it's actually better to give you a width at a different spot. And the W1/2 basically is the width at half height. All right. So what they do is that they take the peak and they measure how tall the peak is. And then they take half of that height. And wherever that crosses up, that's going to be W1/2. Now, there's a reason that we use the width at half height almost a little bit more than the width at the base. And the reason is because we've talked about the problem of chromatograms and how they look. So what if I get a peak that looks something like this? It looks like the peak was coming off like right here. And if this was a true fit column, then my peak shape would be a little bit different. So where on earth do I do this at? Do I do it at width half height, which maybe gives me a more reasonable number? Or do I do this at width at the base? That's kind of problematic too, right? Because that looks a little wider than what it should be. Or what if I get a peak shape that looks something like this? Well, the width at the base would include all of this. That's what the software would see. But the width at half height maybe would only be this piece, and that's exactly what that first component is. It looks like these two components are coming off together really close. So width at half height is actually a better number to use because it gets us away from all of these distortions that can happen in the shape of the peak in the chromatogram. But there's two equations out there, depending on what you have. If you have a textbook chromatogram like this one, then either one of those are proper to use. They'll give you the proper number. They'll give you a roundabout idea of the number of peaks that are inside of that column without a problem. So N for half height and N for width at the base. And that's what these two versions are out there for. So those two equations, I would need to know how to solve and how to use. This one's pretty simple. You take the retention time and you square it. Then you multiply that by 5.55. And then you're going to divide that product by the width half squared, right? You don't do anything with the 1/2. That just represents its half height. You don't do half of an exponent or nothing weird like that. You just take the width at the half height and then you square that number. Keep in mind, do the order of operations. If most people are messing up these two calculations, it's due to the order of operations and they're not plugging it in their calculator with the proper parentheses and doing the steps that they need to be doing in the order that they need to be doing it. So they get a wrong answer because of a careless mistake. So that's calculating N, which is the number of plates, and that's where this video is going to stop. So in the next one, we'll continue on with more equations and more terminology, and we'll eventually drag our feet through the rest of this lecture concerning the chromatography theory and chromatography equations.